limits, I'm going to repeat myself. Shh. Limits are what the value is approaching from the left and right, not necessarily what the value is at that x. So an example. If I give you, come on. I'm going to do blue. If I give you a graph like this, you don't have to draw this. I'm just getting you to wrap your head around what a limit is. So if I go like this, we had this from, pretend that's straight. We had this from rationals, correct? It was a point of discontinuity, Okay, so say this is at 1 and this is at 4. Right, the height is at 4. Now you know that the point doesn't actually exist there because there's an open dot. It's called the point of discontinuity, right? What we're going to do is we're going to find out what the limit is. So we'd say limit, and you're not doing this, just paying attention. Limit as x approaches 1, and we'll call this f of x. Limit as x approaches 1 of f of x. Well, all that means is, from the left and from the right, what is it approaching? It's approaching x as 1, but what is it approaching for your y? 4, because we're doing function notation, right? Technically, we're inputting an x, getting out a y. Now, we know that f of 1, we know does not exist. I'm going to write this because it's my notes and I can do what I want. So f of 1 does not exist. We know that. We agree? But the limit as x approaches 1 does exist. It's at 4. Because it's just what it approaches from the left and the right. So from the left it approaches 4, and from the right it approaches 4, then the limit is 4. Because it's literally just what the y values are as I approach it, not exactly what it is. Now, in order for there to be continuity, in order for the graph to be continuous, this is another thing we'll talk about. In order for the graph to be continuous, the limit as x approaches 1 of f of x has to equal f of 1. What does that mean? Well, the limit as x approaches 1 is what is it approaching from the left and the right. If what it's approaching from the left and the right is the same at what it is, it would just keep going, right? So an example, if I filled this in, say it wasn't an open dot now. We agree? From the left it's approaching 4. From the right it's approaching 4. So the limit as x approaches 1 of f of x is 4. You're not writing this. Yeah, we're going to get there. We're just going to keep going until we get it. Now, if this here, f of 1 is 4, then we know from the left and the right it's approaching 4. And as it goes to the value, it approaches 4. So it's going to keep running. Left, right, it's going to go straight through. So it would be continuous at 1. Because the value at 1 and the limit at 1 are the same thing. It's just what it is from the left and the right. Now, what happens if I gave you one that was like this? I gotta learn how to chill. No freaky outies. No freaky outies. Okay. So, it's calculus. From the left, is this graph continuous? You can tell it's not. So that's good. From the left, what's it approaching? 2. And from the right, what's it approaching at 1? -2. It's the y value. We're just talking about the y values, right? So from the left, this one, when I approach 1, is approaching 2. From the right, this one, when I approach 1, is approaching -2. Do they approach the same thing? No, so the limit doesn't exist. So if they approach the same value, the limit is that value. If they don't, it doesn't exist because there's no limit. Because the limit is just literally like someone telling you from the left and the right at this point, we're approaching this y value. That's it. Why would you need that? Because you guys have always had graphs until this point that are either continuous, or if they have a point of discontinuity from the left and the right, they approach the same thing. What they could do though now is they can give you like something like this with an open dot, just like we had in rationals, correct? And then they can, so this would be at 4, let's say, and then they can give you a closed dot down here. It's just a piecewise function. So the limit as I approach 1, so from the left I'm approaching 4. It's the y value. From the right of 1 I'm approaching 4. So the limit as x approaches 1 of f of x is 4, because from the left and the right I approach the same thing. And if I wanted you to tell me what is f of 1, you should all be able to tell me that. It's from grade 10. Maybe not, if it's from grade 10, but I believe in you. It's just negative 2. It's literally what is the actual coordinate. F of 1 is negative 2. It's what the value is. On this other one that I was drawing, where I kept it as an open dot like it was irrational, remember that? Let's say this is 4. The limit as x approached 1 was still 4, because from the left and the right I still approached 4. But f of 1 didn't exist because there was no dot randomly drawn here as a closed dot, is there? There's just an open dot at 1. It doesn't exist. So it changes depending on what you do. What you need to take home from this is the limit exists if and only if from the right and the left you're approaching the same y value. I don't care what the value is actually at that. So like if the limit as x approaches 1, I don't care what the value is at 1. I don't care. It could be 10, it could be 7, it could be doesn't exist, it could be just like an open dot, it could be an asymptote. I don't care. But in order for a limit to exist, from the left and from the right, they have to approach the same y value. That's it. So, random graphs. Let's just see here. You tell me if the limit exists or not. So if I give you this. This is 2, this is negative 3. Does the limit at 2 exist? Yeah, what is it? It's negative 3, because from the left and from the right, it approaches negative 3. That's it. What is f of 2? Does not exist because it's an open dot. Right? There's nothing there. What is it now? What's f of 2? 2. If they draw a closed dot, then there is an f of 2. If it's an open dot, there isn't one. Make sense? If I give you this. Oh, it's right here. Say that's my graph. This is 1, this is 4, this is 5. What am I approaching from the left? From the left, I'm approaching 4. What am I approaching from the right? 5. What's the limit at 1? Doesn't exist because they're approaching different values. What is f of 1? It's 4 because the closed dot is there and not there. Yeah?
So it's just like a straight line with no dots have a limit?
Yeah. They would just be whatever f of x. So if it's a continuous function, like say it's like this. Those are the easiest to do. Because whatever f of 1 is what the limit is, because it just keeps going. So unless there's a break in the graph, your limit is what f of 1 is, let's say. That's how you know it's continuous, because the limit's the same and the point's the same. So if I ever ask you for a limit of a continuous function at that point, or even the graph isn't continuous, but it's continuous there, the limit is the y value. So an example could be, if I ask you for, let's say on this graph, the limit at negative 4. Well, it's going to be negative 1, because negative 4 is at negative 1, and it just continues to go straight through it. The only time you have to really use brain matter is if there's like a gap at that limit, which is usually where the problem lies. Okay? Now, what they can do as well is they can ask you if the limit doesn't exist. So, for example, here the limit at x approaches 1 doesn't exist on this graph, correct? We agreed? Because from the left it approached 4 and from the right it approached 5. The limit doesn't exist. We agreed on that. So instead, so you would say the limit doesn't exist, but what they can actually ask you is from the left and the right. So they can go, which you've already asked me, so don't let the way that they write this confuse you, because you've already answered me. You said it was 4 and 5. It was easy for you, so don't let this confuse you. So limit as x approaches 1 of, say we label this f of x, limit as x approaches 1 of f of x, you told me does not exist. on this graph. And then you told me the limit as x approaches 1, and how they'll show left is they'll show a little negative sign beside the 1, up like as a superscript, like an exponent almost. So from the left of f of x, that one got a little high. What is it from the left? 4. The limit as x approaches 1 from the right of f of x, what was it? 5. This just means left, that means right. That's it. So they can ask for limits from just the left and just the right, not the limit at the actual value. If it doesn't exist, they'll often go that route. So we're going to actually look at number 1. It says, use the graph of the function f of x to answer each question. You can use infinity. If it keeps going on for life up, that would be infinity, right? Where would infinity and negative infinity happen? From left and right. It would have to go all the way up or all the way down. What would have to be on the graph? An asymptote. If you have a vertical asymptote somewhere, it's going to curve and go shoot up and curve and go down, right? So whenever you have asymptotes, you often have positive or negative infinities from left and right. Okay? And then does not exist where appropriate. So we want, for these ones, these are just grade 10 questions. F of 0, F of 2, F of 3. Fill them in. F of 0, F of 2, F of 3. Remember, does not exist as an option. F of 0, what's my y? Does not exist. There is no other dot down here, and there's an open dot on x equals 0, right? But if there was a closed dot somewhere else, it would. You just tell what it is. So, F of 2. It's at 0, because I'm not asking you what it's approaching. I'm just asking what the heck is y when x is 2. So it's 0. F of 3. It's 3. It's the only closed dot. The other ones aren't closed. So f of 3 is 3, because it's the y value of the closed dot. Okay, the limit as x approaches 0 from the left. From the left. So x is 0 is here. I need to, like, that's just where it is on the number line, on the x-axis. As I'm approaching it from the left, I'm just going to draw. I'm approaching 0 from the left. What's happening? It's approaching what, though? Negative infinity, yeah. The next one is the limit as x approaches 0. It doesn't say plus, it's not from the right, but what would it be? Doesn't ask this. But what would the limit be as x approaches 0 from the right? The limit as I approach 0 from the right approaches 2. So that would be the answer. However, that's not a question on here, right? So the limit from the left, it approaches negative infinity. The limit from the right, it approaches 2. Do they approach the same thing? No. So what's the limit at 0? Does not exist. Because the limit is just, hey, are they approaching the same thing from the left and the right? It's just literally telling you on that side of that point, what are the y values approaching? That's all the limit gives you. It's a very small scope of what the graph looks like. It's just from the left and the right what the graph's approaching. Doesn't tell you if it's a straight line, a curved line, nothing. Just from the left and the right, what are they approaching? Now, the limit as x approaches 3 from the right. 3 from the right. So from the right means I start on the right and I approach it from the right. What's it approaching? 2. The limit as x approaches 3 from the left. Wait, it's not on there. What is it, though? 1. Do they approach the same thing? No, so what's the limit at just 3? Does not exist. Then it says the limit as x approaches negative infinity. So I'm going to approach negative infinity. If I was approaching positive infinity, I'd start and then approach positive infinity. This one's just approaching negative infinity, so I'm going to start running like this. What am I getting? And I know it's doing this because there's a dashed line here. What am I getting closer and closer to? One. They ran a partial asymptote to show you that it's not going to go up further. Okay, give her, try it. F of 0 is what? 0. Okay, F of 2 does not exist because there's actually an asymptote there. F of 3, it's 0. X, as x approaches negative 1, just negative 1, not from the left to the right. But remember, in order for it to exist, you actually have to look from the left and the right and see if it's the same thing. Do you agree? So from the left, what's it approaching? Positive infinity. From the right, left, or from the, oh my gosh, right, what's it approaching? Are they the same? No, does not exist. When you give someone a limit, you're telling them from the left and the right it's approaching that same value. So if you tell me that, which one would you pick? Positive infinity or negative infinity? You wouldn't pick either because neither of them is what it's approaching from the same side, right? So you can't do that. Okay, the limit as x approaches 0. So from the left I'm approaching. From the right I'm approaching. So the limit at 0 is 0. The next one wants the limit is 2 from the right. Well, this would be 2 from the left. 2 from the left would approach positive infinity. Just never asked me that, right? 2 from the right would approach what? Negative infinity. Two from the right. Here's 2. This is right. 2 from the right would approach negative infinity. On the right-hand side of it.
Yeah, that's not the term you used. Sorry. 2 from the right? What?
No, it's approaching 2 from the right. Here's 2 from the right. Not 2 from the right.
Oh.
Do you know what I mean? The sentence, we need a comma somewhere in that sentence. Okay. And then x approaches positive infinity. So we're going to positive infinity this way. What are we approaching on the y? 1. Okay, then we're going to flip over. These are not hard, so stop. Chill. Breathe. You're fine. Okay? We're going to go through the same route. You're going to have a freak out mode, and then you'll come to Jesus moment, and then you'll be fine. Okay?
I'm still freaking out about today.
Okay, but that's not right now. Okay. So, this is just a piecewise function not drawn, yes?
This is not that can be on our test on Wednesday.
All of it. I think the whole test just might be this.
It almost.
The whole thing.
Yeah.
This is easy.
I will give you one as a bonus. Remember I told you that?
Okay, I think
Okay. So here, answer the following questions for the piecewise defined function. So the difference between this and the last one is they gave us a piecewise defined function by equations. They didn't draw the graph. But I believe in you. And I think you can do it. So what the heck does this mean? Piecewise you guys talked about in grade 11 with absolute value functions. So what you're given is you're given a function that with the absolute value ones you basically were just given one line and another line and then you were restricting the domain to both of them. That's kind of what you did. In calculus we go more advanced in the fact that from the left it'll approach one certain value and from the right it'll approach another certain, not value, sorry. From the left it'll approach it'll use a different graph than from the right. So from the left of 1, I would actually draw the sine pi x graph. Good thing is, you're not drawing it. Next one, from x is greater than 1, I would draw the 2x squared graph. So from just, this is all you need to know about this right now, is at 1 is where the split happens, right? On the left of 1, you have a sine graph drawn. On the right of 1, you have an exponential graph drawn. It just looks different. Yes, thank you. Yeah, you don't know, Andre is reenacting it quite well. Now, at 1, is there a value here?
No.
No, why? 1 is greater and 1 is less, but there's no what? There's no equal sign. So since there is no equal sign, f of 1 does not exist. If there was an equal, some people will say, what if it's on both? It won't be. It'll be on one or the other. So you look for it. Say it was on the sine one, then I would plug 1 into here and give an answer. If it was on this one, I'd plug 1 into here and give an answer. That's it. So you would just plug it into the one that had an equal sign to find f of 1. Okay? Now, they want the limit as x approaches 0. Okay? As x approaches 0. This graph has some sort of sine function and some sort of exponential going on opposite sides of 1. We agree? At 0, what's happening? 0 is some sort of sine graph going on over here. There's a 0 and the graph is approaching the same thing from the left and the right. Correct? There's no break in it. It's a sine graph. So how could I find this? Yeah, plug 0 into the x of the sine one, because it's literally going through here somewhere. Correct? So to find the limit, I'm going to do the work over here. The limit as x approaches 0 of f of x, I literally just go sine pi times 0. Because I'm just filling 0 in for the x. Because the graph is the sine graph at 0, correct? What is sine of 0?
0.
Boom. Done. So the limit as x approaches 0 of f of x is 0. This is so what?
Free.
Free.
Range.
Yes. That's what I thought. Yeah. Okay. Now 1 is a different story. Why is 1 different? Because you're going to have to plug it in to find out what it is on the left, which is the sine function. Plug it in, find out what it is on the right, which is the exponential function, and see if they're the same. So I'm going to go, I have to do left and right first. So I'm going to go the limit. If it's where they share, you have to do left and right. So we're going to go the limit as x approaches 1 from the left of f of x. I'm going to plug 1 into the sine equation. Because 1 from the left is when x is less than 1. So I'm plugging it into this one. So I'm getting pi times 1. What's sine of pi? 0. So from the left, this graph is approaching 0. Okay? Yeah.
So, wouldn't there just be one point? Like, isn't it just approaching on one side, then not the other?
It could be approaching them both at the same spot. So for example, the sine graph could be approaching 1, 0 with an open dot, and this exponential could be approaching 1, 0 with an open dot. So they could be approaching the same thing, technically.
Just for 0, the exponential one can even get
Right, so you can't. So for anything less than 1, you'd plug it into the sine. For anything greater than 1, you'd plug it into the exponential one. And the only one that you actually have to plug it into both to see is when it's at the point where they're both at. So it's at 1, the sharing spot. Because what will happen is you might have like a sine graph doing this and then an exponential doing this. So they actually both approach the same thing. They just don't look the same at all on either side. And how do we know that? We have to plug in from the right. So we're going to go the limit as x approaches 1 from the right of f of x equals 2. So I have to plug it into the right one. So the greater than 1. 2 times 1 squared, which is 2 to the 1, which is just 2. So what's happening is we actually have a graph that's going like sine, whatever. It's going to be at 1, 0. So we have the sine graphs approaching that from the left, and the other one is 1, 2. So the sine graph's like doing something like this, and the exponential's doing something like that. So they're not approaching the same thing, right? So then what's the limit at 1? Does not exist. Now what if I asked you for the limit at 4? Where would 4 fit? In the exponential, so I just plug it into the exponential, right? So I would go 2 times 4 squared, which is 2 to the 16. So I'm going to leave it at that. I don't feel like punching it in. Yeah, it's a big stupid number, I agree. So any limit on the left of 1, I'm plugging into sine pi x. Any limit on the right of 1, I'm plugging into 2x squared. 2 to the power of x squared, sorry. The only time I plug it into both is the shared point. So when x is 1. I have to plug it into the left, plug it into the right, see if they match. If they don't match, it does not exist. Okay? And what Santi asked, which was a good question, is what happens if it's continuous? If it's continuous, it's where it is, right? If it's continuous, you just find f of that value. Which, that's why we could do that for the 0, and we could do that for the 4. Because we know the graph is continuous on both sides of that. All right. Try this one out. All right. F of negative 3 over 2 is the same as f of negative 1.5. Does negative 1.5 exist on this graph? No, this graph exists to the left of negative 2, and there's a space between negative 1 and 2, and then 2 to infinity. This graph doesn't exist here. There is no x value at negative 1.5, or t value in this case. F of 2 would get filled into the 3t minus 2 one. So it's going to be 3 times 2 minus 2, which is 6 minus 2, which is 4. And then f at 3 over 2, which is 1.5. Where does that fall? In the middle equation. So f of, I'm just going to do over here because I don't have space, 3 over 2 equals 3 over 2 plus 6 over 3 over 2 squared minus 3 over 2, which is 10.
I got 20 over 3.
Close enough.
You
Put
up
over
somewhere.
2, you'll get 10.
Yeah,
I'll
pretty much
just
the same
subtract 1 on the
I just do this thing back.
All right, D, the limit as x approaches 2. We'd have to go from the left and the right, correct? What's the problem?
Doesn't exist.
There is no right. There's only a left.
Right.
So it does not exist.
left hand, which means it's
What would you fit?
okay.
The left and the right has to approach the same thing. E, negative 1 from the right means a greater than negative 1, correct? So I'm going to fill it into which one? The middle. So I'm going to go 1 plus 6 over 1 squared minus 1. It's a negative 1. Lepp. It's a negative 1. Oops, there we go. So it's going to be 5 over 2.
Wait, why do you use 1 again?
Use negative 1.
I put it in this one.
Does it matter if I'm in the equation? Wait, so you square the negative
It becomes a positive, and then you subtract the 1, and then it becomes a 0.
No, because you're not doing at that value. You're doing from the left, from the right. So from the right of negative 1, you use it as the greater than negative 1 equation.
Okay.
If it was from the left, we'd be in trouble because there is no left.
Where's the negative 1? I've got a negative.
You have to square.
Now, as t approaches 2, we actually have to fill it into the middle and the bottom and see if they match. So I have to do the limit as t approaches 2 from the left of f of x, which means I have to fill it into the less than 2 formula, which is the middle. So I'm going to get 2 plus 6 over 2 squared minus 1, which is 8 over 4. Chillax. 8 over 2, which is 4. The limit as t approaches 2 from the right, we have to plug it into the bottom one. So we're going to go 3 times 2 minus 2, which is 4. They're both approaching. I was trying to make you stop, but yeah. They were both approaching 4, so it is 4 at 2.
No, what's so funny about calculus?
No, it was funny. Okay. Okay. Now, as t approaches 0, quiet please. Which one does it approach 0 on? The middle one. Now, we can break the middle one down. If we break the middle one down, we can do like we did in 30-1. We have t plus 6 over t and t minus 1. This would be a vertical asymptote at t equals 0. This would be a vertical asymptote at t equals 1. Therefore, at 0, there's an asymptote, so it does not exist. They're not going to approach the same thing. All right. Can you guys go into your phones, wherever, technology. I posted a trig review there. Work on trig.